Feel welcome and also appreciated. Yet another lesson which I'm going to look at solving the linear simultaneous equation using the matrix approach. Want to see how to solve the linear simultaneous equations using what we call the matrix approach. My lesson is going to be divided into two. We are going to have a discussion. Then after the discussion, I'm going to provide an example on how to work them. Now let's start with the lesson discussion. Under this discussion, I'm trying to define what a linear equation is and how to convert that linear equation to matrix equation for easy solving. So a system of linear equation can be written as a single matrix equation. Look at this. There is an example provided. So the linear equation will look like 2x minus 3y equals to 10. Negative 5x plus 8y equals to negative 26. That pair of linear equation, we refer to them as simultaneous equation. Now we can change this simultaneous equation into matrix equation as follows. So we are going to take the coefficients of the variables together to form matrix A, and then the variables together to form matrix X, and then the constants together to form matrix B. So our matrix equation is going to be AX equals to B, where A is the coefficient matrix of the system, X is the matrix of the variables, and B is the matrix of constants. So that is the procedure that we follow when you are changing the linear equation to matrix equation before proceeding on to solve it. Now, solution of this linear system. Now, consider that if we let AX equals to B represents a system of linear equations together, and if the determinant of A is non-zero, in other words, the determinant is not zero, then the linear system has exactly one solution, which is given by X equals to inverse of A multiplied by B. Are you together? A should not be a non-zero. In other words, the determinant of A should not be a zero, because if it's a zero, then that matrix cannot have an inverse. So where A inverse is actually the inverse of that coefficient matrix. And also, if I was to provide an example to show how to find the inverse, then I'll say if you're given a matrix A, which is A, B, C, D, then it implies the inverse of A is 1 over the determinant, and then you change the elements of the leading diagonals and introduce a negative on the other diagonal. By so doing, you are getting what we call the inverse. Remember, AD should not be equals to BC, or AD minus BC should not be equals to 0 together. Now, on the working side, I want to provide an example and then use this discussion to try and see if we can master and solve that example. Use matrix approach to solve the linear system below. So the equation given are 2x minus 3y equals to 10, minus 5x plus 8y equals to negative 26. This is a linear simultaneous equation. So the first step is to convert this linear equation into matrix equation. And this is how we go. We begin by writing the equation in matrix form. So it becomes to 2, negative 3, negative 5, 8. Then we have the matrix of variables and then equals to the matrix of constants. Once we have done, then we find the determinant of the coefficient matrix A. And by so doing that one, we'll see the leading diagonals is 8 minus 2, which is 16. And then the other one is 3 times 5, which is 15. So it will be 1 over 16 minus 15 into, we interchange the elements in the leading diagonals and introduce the negative in the other diagonal. By so doing that one, we get the A inverse equals to 8, 3, 5, and 2. Finally, multiply the matrix constant by A inverse to obtain the solution of X. Remember we said X equals to A inverse multiplied by matrix B. By so doing, we have 8, 3, 5, 2, 10, and then negative 6. So remember, we are multiplying row by column. So it will be 8 times 10, that is 80, and 3 times negative 26, that is 78. And then you add. So 80 plus negative 78, we get positive 2. Then we go to the second row, 5, 2, and 10, negative 2. So 5 times 10 is 50, and 2 times negative 26 is negative 52. So 50 minus 52, we get negative 2. So the product of the multiplication of this one end with 2, negative 2 equals to x, y. Now the solution of the system therefore is x equals to 2 and y equals to negative 2. A short brainstorming question, you can make attempt of this. Try this assignment which says use matrix approach to solve the following system of linear equation, that is 2x minus 4y equals to 7 and also negative 3x plus y equals to 12. I hope that this method of matrix has actually been well understood and you can apply it to solve any given system of linear simultaneous equation. Thank you and follow me for more interesting lesson and video to follow. Thank you and be blessed.